Welcome. Today we have the question from Div 2, which is 1925B, a balanced problem set. So let's first understand the question. So here it is telling that Joy managed to create a problem of difficulty X and decided to make it the second problem for this round. So we have X, which is an integer, and it is telling that but Yash fears that this problem will make the contest highly unbalanced and the coordinator will reject it. So he decided to break it up into a problem set of n sub problems such that the difficulties of all the sub problems are a positive integer and their sum is equal to x. Okay, so x should be broken up into n parts, or you can say n sub problems, such that all that parts or problems should be a positive integer. Now, there's a coordinator, which is there's a balance of this problem set as a GCD of all the difficulties of all the sub problems in the problem set, and you have to maximize that balance if he chooses the sub problems optimally. Okay, so what the question is telling is that we have n and we have x. Okay, so this x which is being given to you, you have to divide it x into n parts. Okay, n parts such that n parts, okay, n parts such that all parts sum up to x. Means let's say we divided this x into k1 plus k2 plus k3, okay, and up to kn. This sum equals should be x. Okay, so we have divided our x into this k1 plus k2 up to k3 up to kn, and we have to choose this k1, k2, k3 up to the n such that the GCD of this k1 and k2, like that, GCD of k1 and k2, like GCD of this all k1 comma k2 up to kn should be maximized, right? Should be maximum. Okay, so how we do it? So first understand one thing. If we take GCD of k1, k2, kn, okay, so we can divide this k1 into, we can write this k1 as GCD of this k1, k2. Let's say we say this GCD as g. So we can say that this k1 can be written as I would say g into k1 dash, right? I can write it, no, like if I say 10. Okay, if I take, let's say if I take 10, 15, and I would say I take 25. So what is the GCD of this all? This GCD is 5, right? So I can write 10 into 2 into 5, right? I can write 15 as 3 into 5, and similarly I can write I can write 25 as 5 into 5. So I can write this k1 into g into k1 dash. In the similar way, I can write k2 as g into k2 dash. K2 dash is also an integer. Okay, so what I can do, I can write the equation which was there into g into k1 dash plus g into k2 dash up to our g into kn dash, right? Which is equal to x. Now let's take out this g common, and what we can see is, if we take g common, it is some, let's say k1 plus k2 up to kn dash minus k dash. Let's say we write it as g, sorry, it is g into some k dash, which is equal to x, right? Now what it seems, it has come that g is a factor of x. What we can see from here is that g is now, that g is a factor of x. We can see it, right? So we want to maximize this g. So what I will do, I will not care about this k dash. I will focus on g. I means I will take all the factors of x, right, and I will try to maximize that g, right. Now first of all, understand one thing also. how much I can take that G, means how much at how much point I can make that G maximum. Like let's say you have been, let's take an example of that example only, 420, and like n x is equals to 420 and n is equal to 69. Okay, so my question is, you have known that your answer should be a factor of x, right? Now my question is, it's not that you will always give a maximum like x only. Like a factor g can be x, but it is not always possible, because we can't form n sub problems. So we have a restriction, that our n is our restriction, that will that will decide our that will decide our what is the maximum value of g. So how can we get that? Okay, so let's say this is n. So what maximum uh gcd can be possible? So if I do 420 by 69. Okay, so I get some 6 point something. So I get that maximum I can have a our my this g into k1 dash, g into k2 dash is 6, means I can have like 6 plus 6 up to some 6. Okay, and let's say it's 420. Now understand, it is my maximum that all can have. All this and should have at least 6. I'm not saying that this will add up to 420 at exactly 69 times. We will come to that point. But understand that I am trying to find it what minimum this should be, at least. This g into k1 dash. So from here, I could say that minimum I can have is 6 or more than that. Understand? Or, sorry, means this is my minimum, but all I can't have 7. Right? I can't have 7. This I can't have like 7 plus 7 up to 7 69 times, because it will exceed my 420. It is not 420, it is, I would say, it's greater, right? So I am finding this value such that maximum value such that it remains less than or equal to 420, which I found is 6, and I found this by dividing this x by n. Means your task was to find g into some k dash equal to x, and your g, this g into k dash is limited. I would say your g into k dash is limited by your n. Okay, now see what we will do. Now see, you have this number x by n, x by n. X by n is a number which is g into k1 dash. So the thing is that, let's take an example of 420. What are the factors of 420? You could say 1, 2, 3. You can also say 4, 5, 6, 7, 210. Maybe 420 can be okay. Wait a minute. I'm saying 420 can be a factor of it. No, it can't be. Then 9. So 9 is also maybe not possible. And 10. So we have factors of this, right? Up to I would say 420. There are lots of factors. Now the thing is that your g into k1 dash, your g into k1 dash up plus some g into k2 dash up to your g into kn dash. Now tell me that this part can be maximum as which? This part can be maximum is this range. Means it is below or it is up to left. This can't go 7, right? This can't go 7 up. So my task is to make this g into k1 dash as maximized as possible, right? I don't get this k1. This k1 dash can be 1, can be 2, but I am very sure that this whole has to be, that this g has to be a factor of this 420, and I don't care of what is this k1 dash, k2 dash, and kn dash, right? So what my approach is that I would take all the factors of my x, means take all the factors of x, and then I am limited by my this x by n ratio. So I can have a lower bound for that. Let's say here also, here if we're having one, oh wait a minute, here we are 1 2 3 4 5 6, and we saw that my x by n is 6. So my GCD is limited by 6. And what I can see, I can have, I want that it is equal to or less than. So lower bound gives us greater than or equal to, right? It gives us greater than or equal to. Okay, it gives us greater than or equal to, right? So lower bound gives us greater than or equal to, right? So for finding less than or equal to, I will see that, okay, if it is equal to, means if lower bound is equal to my ratio, if lower bound is equal to my ratio, so if lower bound is equal to, see, I want that my my ratio, which is let's say k, which is nothing but x by n, your g should be limited by this k. Now I am using lower bound, which tells me that you have to find a factor in your that vector of factors, such that in your vector of factors, such that your this factor, I would say this k, your g should be less than or equal to that. Okay, that your g should be less than or equal to. So I will use lower bound to find this thing. How we do it, right? So see, lower bound gives you lower bound gives you an element which is, if I do, I will get what g is greater than or equal to k. If I do lower bound in the vector of factors here, I will get a factor which is g, but I get greater than equal to. So for finding less than or equal to, I will check if it is equal to that k. If my g is equal to k, I'm fine. Or if I'm not equal to, means I have shifted after that. Means let's say you have this vector 1 2 7, then 8. Vectors will always be in increasing order, so that or I can sort it also. Okay, so let's say you have, and now your k is something, let's say it's I would say it's 6, right? It's 6. So lower bound will give 7, but you want that your g is less than or equal to k. It is not equal to, there is no g. So my lower bound will be pointing here. I will one shift it, left shift, no, I will just go left side at one index, and my answer is 2. So for in any question, if you want to found less than or equal to k, you just do it lower bound and take one element before it. Okay, so I think you have understood the problem. I would I would just show that how our answer is coming actually. So let's say it's a 420, and your n is equals to 420, and sorry, your x is equal to 420, and your n is equals to 69. So what is actually happening is, here we got our k, which is equal to 6. Okay, it's equal to 6 point something. So what we did actually, we took a vector here, we took a vector here, uh, we took a vector here, and like it was 1, it was 2, up to 6 7, we got here, and we give our answer. If it's not equal to, we go back if it's not equal to, right? Now what happened, like, okay, so how our answer was framed into 420. You said your 6 is your minimum, like g into k dash became your 420. How? So you know that, okay, let's break it into g into k1 dash. Let's just was 6 plus 6 up to, see, this is if you take 69 times, so it will not, it will be 414. So you can take last element as 12. So 68 into 6 is fine, and then you take 12, so which is equal to 420. You take all the elements as 6, and last element as 12. What we make ensure is that our minimum or maximize GCD 6. I don't care this k1 dash. Here the k1 dash is 1. Here this k1 dash is 1. Here the k1 dash is 2. I don't care. Kn dash is 2. I don't care. I just care to maximize my GCD. Fine. So let's go to code part. So here I have declared index, and I will take input here. And what I will then next ensure is let's have a k which was x by n. Now what I will do, I will found our factors first. So let's say I have a vector which will be in the sorted form, just factors, let's say, and I will find all the factors of that. So I would just use a square root function to find my x, right? And what I will do, instead of using vector, okay, I can use set, which will ensure that it is unique, and it is always in sorted form, so that you can find your factor in logarithmic of time. This was the main thing, as I saw many submissions they were doing in n square type. They're finding this thing in O of n, but by using this set, you can find that maximum factor as from logarithmic of time. Okay, so here just we would say if x modulo I equals 0. So what I will do, I will just say okay, insert into the factors dot insert, okay, your x by I, and you will also ensure that you insert your I. Okay, so from this you have ensured that yes means if your x by I and I same as it is set, it will don't matter. Okay, so your all the elements in the set will be always unique. Now you just need to say okay, if let's say I'm finding my lower bound, so factors dot lower bound, what I want to find the lower bound of my k. So k. Now if if that element is already equal to k, I would give that answer. So my answer will be that. And if it is not equal to k, which we saw here, so which can be possible, so I would just go with previous of that of 1. So this we have used for finding it one element before. So let's say you were having set like 1 2 5 6 7. So if my like let's say lower bound of 4, so it pointing equal to my star it would be equal to 5 if my lower bound of 4 I'm finding. But using this it equal to pre of it comma 1, now it is my star would be equal to 2. This is how it works. So now I'm pointing to it the lesser element than k. I would just print it out. Yes, my answer is done and the question is done. If you have any doubts, you can write it in the comments section. Okay, thank you.